Okay, so remember, this is something we did earlier in the course, right? We had this notion of least common multiple, namely, for any integer n, right? We had this notion of the multiples of n, which are numbers of this form. You know, it's 0, which is a multiple. You have n itself, 2 times n, 3 times n, 4 times n. You're just multiplying that integer n by any non-negative integer. 0, 1 times n, 2 times n, 3 times n, and so on. This is the example with 3. Going a little bit faster than I normally would. Again, you know, this is just review. And from this notion of multiple, we define the notion of the least common multiple of two non-zero integers, m and n. And it's really what it sounds like, almost. You know, it's the smallest positive integer that's a multiple of both m and n. It's the smallest positive integer that's a multiple of both m and n. Okay? It has to be positive, otherwise least would not make sense because there's no smallest negative number. But as an example, this is actually the same one we did in class when we first saw this, 6 and 8. I mean, really, I don't have to include 0 here because 0 can't be the least common multiple. But I did put 0 in both lists. But again, for now, we can just list the multiples of both integers, m and n, in this case, 6 and 8. Okay? And what do we get? Well, we have to get the first positive multiple in both lists, which it looks like is 24. Oh, sorry, wrong button. Yeah, let me get to that. Which turns out to be, looks like it's 24. See if we can draw that in. Okay, good, good. So that's what we get here. I mean, if you know anything about number theory and factoring and prime number factorizations and all that, there are more efficient ways to find the least common multiple. But again, I'm just going by what I taught you in this class. So this is really all we can do for now. All right. Now we can use this to solve this kind of wonderful equation, one with fractions. What you do remember, excuse me, what you must do is you have to get the least common, you get a common multiple of the denominators, a common multiple. What's nice about the least common multiple is it makes the calculations a little bit easier. Namely, the numbers you have to work with are smaller. And also, in the end, the result, if it's a fraction, it's a lot easier to get it into reduced form, in lowest terms, that is, if you use the least common multiple. So anyway, let's do that. Let's use the least common multiple. So we have 2, 5, 10, and 20. So for now, what can we do? All we can do is just list their multiples, as you can see. So we have 2, right? 5, 10, 20. We list a bunch of them and we keep going until we get a positive multiple, a positive integer in all these lists. That's in all these lists. And we get 20, as you can see. I mean, I know 1 is technically a denominator here, but let's ignore it. That's not going to help us. If we put 1 here, that's really not going to help us, is what I'm saying. So we get the least common multiple, right, is 20. Okay, that's great. So we have the least common multiple. Again, we just list the multiples of each denominator enough so that we get something in common with all the denominators. We got 20 here. Okay, so we have 20. Big deal. Now what? Well, we multiply both sides by that 20. And what's going to happen, as you'll see, remember, is these denominators are going to vanish. Right? Multiply both sides by 20. Okay? We do that. Right? And we distribute, as you can see, like so. So we distribute, that's how we get the third equation from the top here. Okay, what ends up happening is there's going to be some cancellation. So for instance, the first term, there's no cancellation because there's no denominator there. Here, with 20 times 1 over 2 times x, right? The 2 goes away. 20 becomes 10. 2 is gone. That's how we get 10x below it. This becomes 60x. Here, right, 2 over 5x times 20. 5 is gone. The 20 becomes 4. 2x. 20 times x over 10. 10 is gone. 20 becomes number 2. Here, the 20s are gone. They cancel, and we're left with 7. So that's how we get the equation here below it. Okay? So we get 60x plus 10x minus 4 times 2x equals 2x plus 7. Okay, let's keep going. We know 4 times 2x is just 8x. 2 times x is 2x, as you can see. Okay, so we can simplify the left-hand side. We end up getting 62 times x. So we have 62x is 2x plus 7. That's good. Almost there, because now we want to solve this equation, which is the same as down here. Great. So how do we do that? Remember, we must get x all alone, right? We have to get x all alone. So we subtract 2x from each side. We get 62x minus 2x, right? That's 60x. 2x here is gone. We're left with 7. 60x equals 7. I brought the 7 over here, make it easier to see, right? We don't want 60x though. We just want x. So what do? Divide. Divide both sides by 60, right? Remember, whatever you do to one side, you must do to the other. You get x here equals 7 over 60. That's what we get. So that's what we get here. And that's our answer. And again, I know, although I said this already, you really don't have to use the least common multiple here. You can use any common multiple. Although if you used another one where you say, I don't know, multiplied all these denominators together, right? I think what you would end up getting is 10 times 10 times 20. And, that's a lot bigger than 20 alone. So you know, using the least common multiple, you can see the numbers aren't terrible. So, okay. Any questions on this? I figured it'd be good to do another one. So here's another one we can do actually. Let's solve this equation. You know, it's the same kind of process, right? Again, we want to somehow eliminate these denominators here, okay? Somehow we want to do that.